Okay, we are now on question 2.4. Question 2.4. In the diagram below, points R, P, A, Q, and T lie on the circle. Points R, T, Q, A, and point P, they lie on the circle. RA bisects angle R. RA bisects angle R. Here is RA. RA bisects angle R, meaning angle PRT. Angle PRT. Therefore, this means what? This means angle R1 will be equals to angle R2. Therefore, if R1 is X, R2 will also be equals to what? X. So we will let R1 and R2 represent what? X, so that we can remember that those two angles are equal. And AB is equals to AQ. AB is equals to AQ. RA and TQ. RA and TQ produced meet at B. RA produced to B. TQ produced to B. TQ and RA produced to B, they meet at point B, meaning RAB is a straight line, TQB is a straight line. Alright, then you can pause the video and do the analysis of the given statement as well as the diagram. Now that we say we let angle R1 equals X, therefore R2 will also be equals to X, then in the diagram identify as many theorem statements that you can, and also try to find the size of other angles in terms of X. Then when you are done, we can continue with question 2.4.1. Question 2.4.1, let prove that AQ bisects PQB. Prove that AQ bisects, here is AQ. Here is AQ. AQ, let me use the green. We are saying AQ bisects which angle? Angle PQB. Angle PQB, meaning we need to prove that angle P2 will be equals to angle, not angle P2, but rather angle Q2 is equals to angle Q3. Then we would have proved that AQ bisects PQB. So we'll first start by saying let angle R1 equals X, and then from there we will say angle R1 is equals to angle R2. This one we're given. Remember, we're told that RA bisects angle R, which is angle PRT. Therefore, our angle R2 will also be equals to X. So we say this is X, and then R1 is equals to X, R2 is equals to X. And then from there, we can say angle Q2 will be equals to angle R2. Do we see that? Angle Q2 will be equals to angle R2. These are angles in the same segment. both R2 and Q2, they are subtended by arc AP. You see, arc AP subtends R2 at the circumference of the circle and also subtends angle Q2 at the circumference of the circle. Therefore, angle Q2 will be equals to X. So now we need to prove that angle Q3 is also equals to X. Then we would have proved that Q2 is equals to Q3. Now, let's look at cyclic quadrilateral R T Q A cyclic quadrilateral RTQA. We see from cyclic quadrilateral RTQA, angle Q3 will be equals to angle R1. These are what? The exterior angle of a cyclic quadrilateral. Let me extend TQ to B. You see, we're having what? The exterior angle of a cyclic quadrilateral. So we can now say angle Q3 will be equals to angle R1. Reason? Exterior angle of cyclic quad. Exterior angle of cyclic quad. Therefore, angle Q3 will be equals to X. Therefore, this means angle Q2 is equals to angle Q3. Since both Q2 and Q3 is equals to, they are equals to what? X. Therefore, we can now say AQ. Indeed, AQ bisects angle PQB. Bisects angle PQB. So Q2 is X, Q3 is also X. Right, now on question 2.4.2, okay, let's first write down the size of angle R1X, R2X, Q2X, and Q3X. Now, question 2.4.2, prove that TR is equals to TB. Prove that TR is equals to TB. Now, TR. Here is TR. Prove that TR is equals to TB. Here is TB. Now, let's look at what? Triangle TRB. Let's have our green triangle TRB. Therefore, for us to prove that TR is equals to TB, what we can do is if we can prove that angle R1 is equals to angle what? B, then we can say TR is equals to TQ, because now this will be what? This will be the sides that are opposite equal angles. So angle R1 is X, therefore it means what? If we can prove that angle B is equals to X, then we will be able to prove that TR is equals to TB. Okay. Alright, then focus on triangle AQB. You see, triangle AQB is an isosceles triangle. AQ is equals to AB. AQ is equals to AB. Therefore, we can say angle B is equals to angle Q3. Q3. Don't just say angle B is equals to angle X. Is equals to X. Remember, Q3 is equals to X, Q2 is equals to X, R1 is equals to X, R2 is equals to X. So first be very clear that angle B is equals to angle Q3. And the reason, these are angles opposite equal sides. Then you can then conclude to say angle B is equals to X. B is equals to X. Now again, going back to triangle TRB, we see that R1 is equals to X, angle B is equals to X. Therefore, we can now say what? TR will be equals to TB. Why? Because these two sides of triangle TRB, these two sides are sides that are opposite equal angles. Therefore, we are saying sides opposite equal angles. These are sides that are opposite equal angles. Therefore, we have proved that side TR, line segment TR is equals to TB. Okay, 2.4.3, we need to prove that angle P is equals to angle TRP. Okay, firstly, R1 is X, R2 is X, Q2 is X, Q3 is X, and B is X. Prove that angle P is equals to angle TRP. Prove that angle P is equals to angle TRP. Now, what is TRP? Angle TRP, it is this one, which is what? X plus X, which is equals to 2X. We can say TRP is equals to X plus X, which is equals to 2X. Therefore, we need to prove that angle P is also equals to what? 2X. Then we can conclude to say TRP is equals to angle P. Angle TRP is equals to angle P. Now, let's have a look at angle P. Angle P will be equals to angle A1. These are angles in the same segment. Both P and A1, they are subtended by the same arc, which is arc RQ. You see, arc RQ subtends P at the circumference of the circle and also subtends angle A1 at the circumference of the circle. Then angle A1 will be equals to what? Let's look at what? Triangle AQB. You see that angle A1 is equals to Q3 plus angle B. Exterior angle of a triangle is equals to the sum of interior opposite angles. Therefore, angle A1 will be what? X plus X, which is 2X. Therefore, if angle A1 is 2X, then angle P is 2X. Then we would have proved that angle P is equals to angle TRP. Okay, let us do that. All right. Now we say angle P is equals to angle A1. These are angles in same segment. Then we say angle A1 is equals to angle Q3 plus angle B. Also this one, don't just say X plus X, more especially if you are not going to mention that you are now working in triangle what? AQB. Just first be very specific that angle A1 is equals to angle Q3 plus angle B. The reason being, this is the exterior angle of triangle. Then angle A1 will be equals to X plus X, which is equals to 2X. Therefore, this is angle A1. Therefore, this means angle P will be equals to 2X. Since angle P is equals to angle A1. Therefore, since P is 2X and TRP is 2X, the two angles will be equal. Angle P will be equals to angle TRP. P. So that is 2.4.3. Then that will be the end of exercise 2.4.